there exists some values of S. There exist some values of S such that S is equal to Z. So, if S is equal to Z, the value of this G of S is equal to 0. Here S will go there. Here the silver సున్నా అవుతుందో ఆ S విలువ ఏమంటాం అంటే 0 of the transfer function అని చెప్పి అంటాం. 0 of the transfer function అని చెప్పి అంటాం. So 0 of the transfer function is the value of S where at which the magnitude of the transfer function equals to 0. ఇక్కడ if you take the G of S and a value in the numerator, take this A by B is a fraction, right? So G of S is combination of two polynomials. One polynomial in the numerator, another polynomial in the denominator. So suppose if this value is equal to 0, denominator లో ఉన్న value 0 అయింది అనుకోండి, అప్పుడు G of S value ఏమవుతుంది? The value of G of S will also become 0. So here we define 0 of a transfer function as the roots of numerator polynomial. The roots of the numerator polynomial are known as zeros. So, here my question is, you are asked to find poles and zeros of the transfer. First we try to find 0, then we try to find what is the pole. Okay. So, the numerator value must be equal to 0, right? So in the numerator, what I am having S square plus 4 into 1 plus 2.5s. These two values, this product must be equal to 0. This product must be equal to 0, right? So either S square plus 4 may be equal to 0 or 1 plus 2.5s may be equal to 0. There, two values A and B to multiply A with B so that the product is equal to 0. In such cases, what happens? Either A must be equal to 0 or B must be equal to 0, right? Like that. Either this value may be equal to 0 or this value may be equal to 0. So, if S square plus 4 is equal to 0, S square is equal to minus 4, or S is equal to plus or minus J2. Similarly, 1 plus 2.5 of S is equal to 0. So, here, if I solve this, 2.5 S is equal to minus 1. S is equal to minus 1 by 2.5. So, the values of the transfer function are, there are three zeros for this transfer function. There are S is equal to minus 1 by 2s, and s is equal to plus j2 and s is equal to minus j. These are the zeros for the given transfer function. Okay, I hope you understood how to find out zeros of a transfer function. So, 0 is the value of s which makes the transfer function value equal to 0. At the particular value of s, the transfer function value is equal to 0. So, అవుతుందా లేదా మనం చూద్దాం. ఎలా చూస్తామంటే first I am taking this value. S is equal to minus 1 by 2. S is equal to minus 1 by 2.5. Sorry. Minus 1 by 2.5. So wherever you find s, there you substitute minus 1 by 2.5. Okay? If this value is equal to 0, then we can say that s is equal to minus 1 by 2.5. Here this is having this 0 value. So the value of g of s, s is equal to minus 1 by 2.5 is equal to minus 1 by 2.5 whole square plus 4 into button rasam. The value of g of s is equal to s is equal to minus 1 by 2.5 equal to 1 by 2 into minus 1 by 2.5 whole square plus 4 into 1 plus 2.5 into minus 1 by 2.5 divided by minus 1 by 2.5 whole square plus 2 into 1 plus 0.5 into minus 1 by 2.5. So 1 by 2 అట్లానే ఉంటది into minus 1 by 2.5 whole square అంటే 1 by 6.25 plus 4 into 1 2.5 will get cancelled, 1 will remain here, plus into minus 1 divided by the denominator value 1 by 6.25 plus 2 into 1 minus 1 by 5. 0.5 will go 5 times into 5. So numerator 1 minus 1, 0. Something into 0 is equal to 0. So we can say that s is equal to minus 1.25 is a 0 for the given transfer function. Okay. Next, we see if you substitute the value of s is equal to plus j2, you will get g of s value equal to 0. Similarly, if you substitute s is equal to minus j2, you will get the same value. Okay. So, what is a 0 now? It is the root of the numerator column. 0 of the transfer function is the roots. Roots of the transfer function are the roots of numerator polynomial are known as zeros of the transfer function. Okay. Now, we see What is the pole? Pole of a transfer function is defined as the value of s at which E of s will become infinite. The value of s at which E of s will become infinite. So, there exist some values of s tends to p, where if s value is equal to this p, then E of s value will become infinite. E of s value will become infinite. That value of s are known as poles. Okay. Now we see what are the poles of this transfer function. In general, in any fraction, if value in the denominator is equal to 0, then that fraction value is undefined, will tend to infinity. So, to take the denominator polynomial, the polynomial that was present in the denominator, to equate this to 0. And solve for s. Here we have two different factors, so that s square plus 2 is equal to 0 and 1 plus 0.5 s is equal to 0. S square is equal to minus 2, s is equal to plus or minus j root 2. Here 0.5 s is equal to minus 1, s is equal to minus 2. So, s is equal to minus 2 and s is equal to plus or minus j root 2 are known as poles of the transfer function. We see whether it is a pole or not. We see. I am taking the value s is equal to minus 2 and this value I am substituting in this E of s. Let us see what happens. E of s is equal to minus 2. This value I am taking. 1 by 2 into minus 2 whole square plus 4 into 1 plus 2.5 into minus 2 divided by minus 2 square plus 2 plus 1 plus 0.5 into minus 1 by 2 into numerator minus 2 square is 4. 4 plus 4, 8 into 1 minus 2.5 into minus 2. 1 plus 2.5 into minus 2. 2.5 into minus 2 is minus 5. 1 minus 5 is minus 4. 8 into minus 4 divided by, in the denominator, minus 2 square plus 2. Minus 2 whole square is 4 plus 2, 6 into 1 minus 0.5 into minus 2 minus 1. So 1 minus 1 that is equal to minus 16 divided by 0 is equal to infinity. So The poles of a transfer function are defined as the roots of the denominator polynomial. The roots of the denominator polynomial are known as poles of the transfer function. Okay. So, what are zeros now? Zeros are the roots of numerator polynomial of the transfer function are known as zeros, and the roots of denominator polynomial of a given transfer function are known as poles. Next. S is a complex term. If you observe, we have determined the roots, poles and zeros of the transfer function. If you look at the value of S is complex quantity, right? Sometimes its value is equal to say plus or minus J2, and its value is equal to S is equal to minus 1 by 2.5. Minus 1 by 2.5 can be written as imaginary value equal to 0. An imaginary value, any imaginary quantity can be written as 0 as the real quantity and the imaginary value. So, either the poles and zeros of a transfer function are complex quantity. Okay, and this complex value is known as angular velocity. So in general, this is represented with sigma plus j omega. In general, this is represented with sigma plus j omega. It may be sigma plus or minus j omega, where omega is known as the angular velocity of the light. Okay. After that, we define type and order of a system. First, we see what is meant by order of a system. The order of a system is defined as the highest degree of S in the denominator polynomial. The highest degree of S in the denominator polynomial is known as the order of a system. For example, you look at this transfer function. You take this transfer function into consideration. Here, if you multiply here, S square term is there, S term is there. If you multiply these two factors, you are going to get the highest power of S is 3. Highest power of S is 3. So, this transfer function is said to be having an order of 3. This transfer function is said to be having an order of 3. And I can say that it is a third order system. I can say that it is a third order system. Okay. So, what is the order of the system? It is the highest degree of S in the denominator following. The highest degree may be any. value. In general, we deal with the systems that are having highest degree is equal to 2, 3, up to maximum 4. But in general, we take nth order system. We take order of the system as n. That means s power n, s power n minus 1, s power n minus 2, like that you will get. If you put n is equal to 2, s square, s power n is equal to s square. S power n minus 1 is equal to s power 1. S power 0 is equal to s power 0 is equal to 1. Like that. Okay. If you take n is equal to 4, then s power 4, s cube, s square, s power 1. Like that you will get the polynomial terms in the denominator polynomial. So, the highest degree of s in the denominator polynomial is known as term of a parameter. Next, coming to type of a system. The type of a system is defined as the number of poles that are present having a root that s is equal to 0. Not I can say that a root, a value that s is equal to 0 will specify the type of a system. That means we will explain the concept of S-plane in the preceding classes. For the time being, you remember like this. The number of poles that are having a value at s is equal to 0. Means ఏదైనా ఒక పోల్ యొక్క విలువ 0 అయితే దాన్ని ఆ సిస్టమ్ ఏమంటాము అంటే టైప్ అని చెప్పి అంటాం. ఇక్కడ మనం తీసుకున్న సిస్టమ్ యొక్క పోల్స్ s is equal to plus or minus a√2 and s is equal to minus 2. These two values are not equal to 0. Right? I can say that no pole is having s value equal to 0. Here are the no pole is having s value is equal to 0. So, type of the system is zero. The system యొక్క type ఎంత 0. Okay. I hope you understood. I will give you an example for a type 0 system. Type 0 system transfer function will be like this. This is a type 0 system. Type 1 system transfer function of the choose. So, if you equate the denominator polynomial, you won't get x is equal to 0. So, this system is a type 0 system. Okay. But you take this denominator of this polynomial, here s is equal to 0. Means one value of s is equal to 0. That is why it is called as type 1 system. And the highest power of s here is equal to 2. So it is type 0 order 2. ఇక్కడ ఈ s ని s square తో మల్టిప్లై చేస్తే వాట్ ఈస్ ది వాల్యూ రిజల్టింగ్ వాల్యూ s into s square, s cube. The highest power of s is 3. So type 1 order 3 system. Type 1 third order system. Like this, we can define the type and order of a square. I will give some examples for you. First order type 1 system. E of s is equal to 1 by s. This is called as first order type 1 system. Okay. Second order type 1 system. E of s is equal to 1 by s into s 1 plus s tau. Second order type 1 system. Okay. Next, second order type 2 system. E of s is equal to 1 by s square. This is second order type 2. I hope you understood the difference between order and type of a system. Right? 4 zeros ఇస్తాను దాని ట్రాన్స్ఫర్ ఫంక్షన్ చెప్పగలరా? The poles of a transfer function are P1 is equal to minus 2, P2 is equal to minus 3, and P3 is equal to 0. These are the poles. The zeros are that1 is equal to minus 1, that2 is equal to minus 2. Can you tell me the transfer function? Any of you? Transfer function ఎలా చెప్పొచ్చు తెలుసా? సరే, the first question. What is the order of the transfer function and what is the type of the transfer? ఆర్డర్ ఎంత అవ్వాలి? ఎంత ఇవ్వగలుగుతున్నాము? మనకు తెలియదు కదా. ఏది తెలియనప్పుడు మనం ఏం చేయాలంటే s is equal to minus 2 అనుకోండి. ఈ మైనస్ 2 ని ఈక్వల్ టు ది పక్కన తీసుకొచ్చాం అనుకోండి, s plus 2 is equal to 0 కదా. రెండోది s is equal to minus 3 అనుకోండి, s plus 3 is equal to ఏమవుతుంది? 0 అవుతుంది. మూడోది s is equal to 0 అంటే డినామినేటర్ ఏముండాలి? s into s plus 2 into s plus 3 ఉండాలి డినామినేటర్. ఇదే కదా, వీటినే కదా మనం పోల్స్ అనేది. s వల్లనే కదా మనం పోల్స్ అంటుంది. తర్వాత 0 చూద్దాం. s is equal to minus 1, z1. s is equal to z1 చేయండి అమ్మా. z1 విలువ ఎంత? minus 1. s plus 1 is equal to ఏమవుతుంది? 0. అలానే s is equal to z2 చేయండి. z2 విలువ ఎంత? minus 2. అంటే s plus 2 is equal to 0. ఇవన్నీ ఎక్కడ ఉండాలి? జీరోస్ అంటే న్యూమరేటర్ లో ఉండాలి అని చెప్పాను. 4 తీసుకున్నాము. ఓకే, 10 ప్లస్ 4 202 క్యాన్సిల్ అయిపోతుంది. s plus 1 into s plus 4 is equal to b of s. ఇప్పుడు ఆర్డర్ చెప్పండి నాకు, ఎన్ని పోల్స్ ఉన్నాయో అన్ని s టర్మ్స్ వస్తాయి డినామినేటర్ లో, లేదా s plus 2 s plus 3 అని టర్మ్స్ వచ్చినాయా లేదా? కాబట్టి వీటన్నిటిని మల్టిప్లై చేసినప్పుడు ఎంత అవుతుంది? హైయెస్ట్ పవర్ ఆఫ్ s s క్యూబ్ అవుతుంది. ఆర్డర్ ఇస్ ఈక్వల్ టు ఒక ట్రాన్స్ఫర్ ఫంక్షన్ యొక్క ఆర్డర్ ఎలా చెప్పుకోవాలి అంటే, the order of the transfer function is equal to its poles. మనకి 3 పోల్స్ ఉన్నాయి మనకి ఇచ్చిన దాంట్లో, T1, T2, T3. Number of poles of the system is equal to T. Okay, so ఒక ట్రాన్స్ఫర్ ఫంక్షన్ యొక్క ఆర్డర్ ఎంత సమానం అవుతుంది? The order of transfer function is equal to its poles. ట్రాన్స్ఫర్ ఫంక్షన్ యొక్క ఆర్డర్ ఎంత సమానం అవుతుంది? దాని యొక్క పోల్స్ సంఖ్యకు సమానం అవుతుంది. మనకి ఇచ్చిన ప్రాబ్లం లో నంబర్ ఆఫ్ పోల్స్ ఎన్ని ఉన్నాయి? 3 ఉన్నాయి. కాబట్టి ఆ ట్రాన్స్ఫర్ ఫంక్షన్ యొక్క ఆర్డర్ ఎంత అవుతుంది? 3 అవుతుంది. ఆ ట్రాన్స్ఫర్ ఫంక్షన్ యొక్క ఆర్డర్ ఎంత అవుతుంది? 3 అవుతుంది. సెకండ్ వన్, టైప్. ఇందులో ఏ పోల్ మీద అయితే 0కి సమానమైందో చూడండి, అలా ఎన్ని పోల్స్ ఉన్నాయో చూడండి. ఇది 0, ఈ పోల్ విలువ 0కి సమానమైంది అంటే ఒక పోల్ ఉంది అన్నమాట, 0కి సమానమైన విలువ కలిగింది. ఇట్ ఈస్ ద టైప్ 1 సిస్టమ్. ఆర్డర్ ఆఫ్ ద సిస్టమ్ ఇస్ 3, టైప్ ఆఫ్ ద సిస్టమ్ ఇస్ ఈక్వల్ టు 1. టైప్ 1 థర్డ్ ఆర్డర్ సిస్టమ్. మరి జీరోస్ యొక్క పని ఏంటి సార్ అని చెప్పి అడగవచ్చు. జీరోస్ యొక్క పని ఏమిటి అన్నది నేను రూట్ లోకస్ చెప్పేటప్పుడు చెప్తాను. ఓకే, సో హియర్ టైప్ లోను ఆర్డర్ లోను జీరోస్ డు నాట్ హ్యావ్ ఎనీ ఇంటర్ఫరెన్స్. ఓకే, టైప్ లోను ఆర్డర్ లోను జీరోస్ ఏ రకమైన సమయము కలిగి ఉండవు. Okay, so this is what about type 1 and type and order of a system. In this class, what we learned, you know the definition of a pole and a zero, and I exposed you to how to find out the poles and zeros of a transfer function. Then from the given transfer function, how to derive the type and its order అన్నది చెప్పాను. తర్వాత వివిధ పోల్ లొకేషన్స్ ఇస్తే, పోల్స్ విలువలు జీరోల విలువలు ఇస్తే ఒక ట్రాన్స్ఫర్ ఫంక్షన్ ని ఎలా రాయాలో చెప్పాను. This is what I taught you in this class. So the next class, I will explain you how to divide a polynomial that is containing the numerator and denominator into smaller fractions with the help of partial fraction expansion. Partial fraction expansion ఉపయోగించి ఒక ట్రాన్స్ఫర్ ఫంక్షన్ ని చిన్న చిన్న ఫ్రాక్షన్స్ గా ఎలా మార్చొచ్చు అన్నది నేను మీకు నెక్స్ట్ క్లాస్ లో చెప్తాను. సో